if we look at 4 is going to be this symbolic manipulations, and so it's going to focus on units 2 and 3 from the AP curriculum, but we're going to see often here the same type of question with FRQ number 4. So let's get started. So our very first part, we don't need to go ahead and read everything above. Let's look down below. We're provided G and we're provided with H. Part 1 says, write a single natural log without negative exponents in any part of the expression. Your result should be in the form of ln. Okay, let's get started. You ready? So this goes back to what we talked about when I gave you the formula sheet. And I said, hey, you've got to memorize these things. And so these all are going to do with FRQ4. So if you have this inside your folder, please write FRQ number 4. These you're going to see over and over again. And I remember students from last year saying, like, I forgot how to basically correctly manipulate different expressions or equations using those properties. Okay, ready? Here we go. So we both have log base E, right, or ln. So I can write this as g of x, and I should probably grab a piece of paper and give myself a little extra space. Let me do that right now. So I'm going to start with, this one is just g of x. They want a single one. So g of x is equal to, and I have the ln of x. Now this value out front becomes the exponent as I'm starting to compress this. Subtract ln of x to the 1/2. Now as I compress against, those coefficients become exponents, and then as we compress, addition becomes multiplying and subtraction becomes division. So now I have g of x equals the ln of x to the 3rd over x to the 1/2. When you have the same base and you are dividing, you're going to subtract the exponent. So I'm going to come down here and write x to the 3rd, subtract 1/2. Okay, so 3 over 1 subtract 1/2. I need to have a common denominator, times 2 times 2. So I end up with 6 over 2 minus 1 over 2. So I have 5 over 2. So I have x to the 5/2. So g of x is equal to the ln of x to the 5/2. Remember, don't circle that. Why? Why should we not circle it? Because if we circle it, it negates all of this work that I'm supposed to show. Okay? Just curious, for those that are in front of me, raise your hand. Were you able to achieve the same simplified answer? All right. Better question. Nobody was able to do it right here. 1 through 5. Who was able to understand that? 1 through 5. Okay, let's go on to the next one. By the way, there's nothing to say that when you get to your test, you're like, I want to start with question 4 instead of question 3 because I feel more confident in question 4 than question 3. You can do that. I'm going to fold this. Look right now. Now, in part 2 of A, so this is 1 point. Here's our next point. We're going to rewrite this. Oh, I got to go back here. I forgot something really important. This is very, very important. Does anybody remember when we're working with logs? I'm going to just write this down right now. When we're working with logs, these two values right here have to always be greater than 0. Did everybody hear that? They have to be greater than 0. So come back up here, and we're going to write down x must be greater than 0. That's important. So this is true when x is greater than 0. So we got to state, are there restrictions on your domain or your input values for that function? Glad I thought of that. Almost forgot. Okay, let's go to the next one. Okay, so I'm supposed to rewrite this where I only have cosine. Well, when I look in the numerator, it looks very similar to sine squared plus cosine squared equals 1. I'm going to see if I can manipulate that to equal cosine squared minus 1. So if I subtract 1 to the opposite side, and remember all these things that a lot of you just would do in your head, we're going to show all of our work on the actual test. Okay, so at this time I have sine squared x minus 1 equals negative cosine squared x. Okay, so I've manipulated this basic, most common trig Pythagorean identity to now I can replace the numerator with negative cosine squared. So I'm just going to continue this thought process. So I have h of x equals negative cosine squared. By the way, remember cosine squared is the same as cosine x times cosine x. And it's all over cosine of x. My entire goal is to rewrite this expression with only cosine of x. So we want to put it in simplified form. These simplify down to 1, and before I can say I'm done, I need to talk about any restrictions. So just like I talked about in the first part when we use the ln, which ln is log base c, we spoke about how these values can never be can never be negative or equal to 0. Well, we have a fraction here. What do we know about a common rule with fractions? The denominator can never be 0. So we're going to write when, so look up here, when the cosine of x does not equal 0. So I looked at what the denominator was, I took that part of the expression, and I stated it can never be equal to 0. Moving on right now to part B, let me see if I can flip this over. So part B asks us, the first part of B says, solve this first equation, and we want to solve it, and we want to choose values that are in these intervals. Got it. Okay, so I want to take, if I'm solving this, notice I'm going to replace j of x with 0. So I do want to show all of this work. So I have 0 equals 2 sine of x times the cosine, sorry for the sloppiness, times the cosine of x minus the cosine of x. I can see that both the left and the right contain a cosine, so I'm going to factor out a cosine. So the cosine of x times 2 sine of x minus 1. And let's just make sure I've done that right. So this is 2 sine of x, cosine of x. Okay, that looks great. So if this statement is going to be true, think of this as two branches. Either this equals 0 or this equals 0, or maybe they both do. So let's go ahead. The cosine of x equals 0. 2 sine of x minus 1 equals 0. Now you're not going to be given a unit circle. These are things you have to have memorized. So notice it also says that it wants us to choose values for x that satisfy this statement, and these values have to be between 0 and pi over 2. It can include 0 and it can include pi over 2 based on having brackets. Okay, where is the cosine equal to 0? That's like the x value. Where is x equal to 0? At these 2 points, at pi over 2 and at 3 pi over 2. But the solutions can only come from this. So I know that one solution is going to be pi over 2. Make sure not to circle it. I literally wanted to circle it and I held back. Let's go to the next one. I'm going to add 1 to both sides. I have 2 sine of x equals 1 divided by 2 divided by 2. I have the sine of x equals 1/2. Now myself, I'm coming off to the side, and I'm literally doing this quick count. 1, 2, 3, 1, 2, 3. Now I know 2's are on the bottom. I know the square roots are on the 2's and 3's. But I'm looking, where's the sine equal to 1/2? Sine is the second number in the ordered pair. That's right here. So yes, I know sines are equal to 1/2 at pi over 6 and over here at 5 pi over 6, but it has to be in this interval, which means x is equal to pi over 6. Again, do not circle it. So I think part 2 is looking a little more complex. So just like we set j of x equal to 0, now I'm going to set k of x equal to 3e. So I have 3e equals 8e to the 3x minus e, and I'm supposed to solve in the domain of k. Okay, so let's start by adding e to the opposite side. So I have 4e equals 8e to the 3x. Okay, then I'm going to divide by 8. And so I have e to the 3x equals 1/2 e. Okay, I'm just taking all this in here. So I'm going to write this as e to the 3x equals e over 2. Okay, now in order to remove this e, I'm going to take log base e, which is the same thing as ln, so you're free to write ln. Now on the right-hand side, these are going to be eliminated, and I have 3x equals, and again, we can go back and write this as ln. That would be just fine. I'm just making sure I'm not making any mistakes here. I'm feeling, okay. So I right now am going to write this as, I'm going to take this and I'm going to expand it. So remember, when you expand it, when you condense it, subtraction turns to division, and when you when you expand it, the division turns into subtraction. So I'm going to write log base e of e, division turns into subtraction, log base e of 2. And you're welcome to write ln instead of log base e. In fact, the majority of people will. Log base e of e means e to what value equals e? Well, e to what value equals e? It doesn't matter if this was 5. 5 to what value equals 5? The answer is 1. So this is equivalent to 1. So I have 1, subtract, and if you want to write ln of 2, it's the same as log base e. You're not going to have any points taken off. And now to isolate, we're going to divide by 3. So 1 subtract the ln of 2 divided by 3 equals x. And do everything in your power to always go back and make sure that you have not circled anything. Okay, we are moving on right now, and we are looking at part C. Let me grab another piece of paper. All right, so now in part C, we have the function m is given by the following. Find all input values in the domain of m that yield an output value of 9/2. So we're going to have an infinite number of general solutions. Just like we did for part B, we're going to take 9/2 and set it equal to this. So we have 9/2 equals the cosine of 2x plus 4. I'm going to start by isolating this portion. So let's subtract 4 from both sides. So 9/2 minus 4 over 1 equals the cosine of 2x. I'm going to go ahead and find a common denominator. You can do that butterfly method if you like. I have 9/2 minus 8 over 2 equals the cosine of 2x. So I have 1/2 equals the cosine of 2x. Okay, so let's take for a second and let's set u. Let's do a u substitution. Let's set u equal to 2x. So let's write down, and I'm going to write it down. I just prefer for some reason to have the cosine on the other side. So let's write the cosine of u equals 1/2. I could have put 1/2 equals the cosine of, equals the cosine of u. I just like it like this for some reason a little bit better. Okay, let's go back to this unit circle. Where do I find the cosine equal to 1/2? So I have 1, 2, 3, 1, 2, 3. Cosine is the first one, so it's right here. So that's 60 degrees, and then all-star trig class tells me the cosines would also be positive down here at 60 degrees down below. So I'm going to come up here. I know this is pi over 3, and this is 5 pi over 3. Can I have a thumbs up or a thumbs down so far if you're following me? Now we want to have a general equation. So let's start this right now. We'll start with u. So we have u equals pi over 3 plus 2 pi n. Because this is going to tell you, you can go around this unit circle as many rotations as you want. If you add an additional cycle, you're always going to add here. Same thing here. And then u equals 5 pi over 3 plus 2 pi n. N represents any integer. That allows you to go around in either direction. You'll land here. But what is u? U is actually what? 2x. So let's go back. We are one step away from being done. So we're going to write 2x equals pi over 3 plus 2 pi n. And now in order to isolate the x, that's our whole goal, we need to get rid of the 2. So dividing by 2 is absolutely true, but that's the same as multiplying by 1/2. So I'm going to take this entire thing and I'm going to multiply it by 1/2. So on the left-hand side, I get x. That's exactly what I want. Now on the right-hand side, I have 1 pi over 6 plus, now I need to take it and multiply here. 1 times 2 is 2. 1 times 2 is 2. So 2 over 2 is the same as 1 pi n. Let's do the same thing over here. 2x equals, and now I'm going to do the 5 pi over 3 plus 2 pi n. Exact same thing. We're going to multiply by 1/2 on the left and 1/2 on the right. So on the left, I end up with x equals, 5 over 6. So 5 pi over 6 plus 1 times 2 is 2. 1 times 2 is 2. 2 divided by 2 is 1 pi n. Now we still have to define what n is. That's important. N is any integer value. Again, everything wants me to circle this as my answer. We need to show the work in order to achieve that.